The statistics around how long it takes to get a code review are kind of depressing. The median is something around 10 hours. The average is something around 20 hours. The best cases, like the P90, P95s, are like 3 hours. We're re-entering a world where more code changes than ever because agents and autocompletes have really created an explosion of code. Now the code review is more important.
Greg Foster is the CTO and co-founder of Graphite, an AI-powered code review platform backed by Anthropic, helping teams like Snowflake, Figma, and Perplexity ship faster with confidence.
What is the best use case for AI code review?
I am very convinced that from here on out, forevermore, every single code change will be scanned by an LLM. If your company uses CI and your company runs linters, they're also going to run an AI code reviewer.
Graphite has a high velocity of software development. What is your superpower?
Our team is in the P99 of productive engineering teams. If you're trying to sell productivity, you better be the most productive team around. We use aggressively every tool that we build. We are stacking. We're breaking up our code changes. With a small code change, you're going to get reviewed faster. The feedback per line of code you write is so much higher.
Explain what is Stack PR?
The Facebook engineering team, they've been doing this for a decade plus. But the idea of branching off a branch off a branch, you unlock parallelization. How do you make anything faster in software engineering? You parallelize it. Can I parallelize these annoying waiting times, waiting for a review, waiting for tests, waiting for deployments, and keep writing code changes on top of it? There's a lot of concern, like, is coding and engineering as a profession gonna die off? And I think that that is a shallow mindset because to me, the profession of engineering is
Hello everyone, welcome back to another new episode of the Tech Lead Journal podcast. Today I'm very excited to have Greg Foster, the CTO, co-founder of Graphite.dev, right? So maybe you have heard about Graphite, maybe you don't, but Graphite is one of the cool developer tools that people use to improve their developer productivity, especially around those pull request workflows. So Greg, I'm very excited to have you on the show. I think we are gonna learn a lot about how to do PRs, code reviews, those kind of things, and how to build a high-performing engineering team.
amazing. Thank you for having me, Henry. I'm excited to talk about this stuff. This is my favorite topic area. So anytime I have a chance to speak about it, I love it.
So Greg, first, let me invite you to probably tell us a little bit more about your story, right? I'd like to invite my guests to actually share by sharing maybe career turning points that you experienced in your career so that we can probably learn from that.
Sure thing. I can share a little bit briefly about my career up until now. It's not too long, so I can cover it. I'm excitedly turning 30 in a month, which means I'm both kind of young, but also means that I've been coding for about half of my life. I think I started when I was like 14 or 15. The way to make money in high school. I was making early iOS apps. I fell in love with engineering. I went to college. Not only can I do it on the side, I can now do it for my main coursework. And I actually met the two people I now co-found with really early on in college. We were all obsessed with engineering and the idea of creating a company one day. We became really fast friends. Every summer I'd go out to San Francisco and do internships at amazing places like Google and Airbnb. I ended up coming back to Airbnb full time, originally as an iOS engineer because that's what I was doing in high school. So I had a pretty good skill set for it. But funny enough, like the first day I came aboard, they said, "Hey, iOS engineering, that's great, but actually, we need you on this infra team." So immediately I guess reorged and swept onto a backend infrastructure team where I found myself working on notification infrastructure, which then cascaded into dev tools and internal developer environments and continuous delivery platforms and release management software. I was doing all sorts of stuff. I was volunteering for SRE rotations, you name it. And I fell in love with infrastructure. I was like, iOS engineering, that's cool, but I'm even more intrigued and just fascinated by building for other software engineers. What does it mean not only to build something good? I'd build pretty good iPhone apps. So what does it mean to not to build something good, but to how engineers can build good things and how can developers be more productive? And that meta question just really fascinated me. And I just started working with the most interesting people. And then right around the start of 2020, I moved to New York. I was staying in touch with those friends from college, Meryl and Tomas. They were out in New York City. I was in San Francisco. We had always wanted to create something together, and we saw this chance to take this passion we had around dev tools and not just do it internally at a company, but to create a dev tool company and then serve and build for everyone. It's cool to build for 1,000 people at Airbnb. It's even cooler to build for all the engineers in the industry. So it was kind of a no-brainer. It was a space I loved. It was people I loved. I moved out to New York. The pandemic came crashing down, which was actually kind of perfect because then we just buckled down, indoors and spent like a year or two coding. As the world opened up, we were also starting to flourish as a startup. And from that 2020 to 2025 now, we have just been continuously working and building and creating a team and everything. And it's really coming together now.
Well, thank you for sharing your story. I think it's pretty interesting, right? The kind of like twist and turn you kind of like experience in your career. I was intrigued when you say you're kind of like still young, right? Like maybe turning 30 soon. And you mentioned that in the beginning, maybe at 15, you started coding, you fell in love in engineering. I think at this age, many people thinking about starting in engineering, right? A bit concerned about the impact of AI. Should they start doing software development, computer science, those kind of things? What is your
Mhm.
view, especially you represent people who just kind of like in the middle stage of the
Yeah.
career, right? So what do you think about this?
Oh, I think it's a golden age to get involved in software engineering. I think it's such a great time. I think about my experience. You're right. Like it's a middle age. There's people, there's some people who learn engineering before me. There's people who learn it after me. When I learned it, it was a little bit tough. I remember I was trying to figure out how to code. I wanted to learn how to code. And I would go online, I'd look up tutorials or I'd look up books, and every resource I found, it would be like, okay, we're going to teach you Java. So given that you know C, here's how to map that to Java. And I'm like, I don't know C. They're like, given that you know Java, here's how we're going to learn Python or Rails. I'm like, but I don't know that. I'm like, it wasn't until I found Coding for Dummies book that was willing to walk me through the primitives of Java from scratch. I read that book. There was an iTunes University course from Stanford on iOS engineering, and I loved it. I was so excited. And I was like on my Windows iTunes thing, watching this video and stuff. And I was working my way through and trying to figure out how to build an iPhone app and get into coding. I think it's so much easier now to get over that initial learning curve. You have incredible resources and tutorials. Heck, you got chatbots that are going to unblock you and can like help debug your program. So the entry point curve has gotten easier, but I think the upper end and the complexity and the amazing things you can build is just as interesting and hard as it was before. I don't think that that's like a solved problem. And even at the heart of it, I know there's a lot of concern, like, is coding and engineering as a profession gonna die off? Like, is this not a good time to invest your skills into that? What if it's not here in 5 years? And I think that that is a shallow mindset because to me, the profession of engineering, the art of engineering is one of solving problems and building things. I think it's very timeless and it's here to stay. It's been people have been solving problems and building things for thousands of years, and I'm just really positive we're gonna be doing that in 100 years from now too. Now, coding, typing my fingers on a keyboard and getting stuck on bugs, that's definitely changing and evolving. And we can have a fun debate around to what degree we're going to be typing versus giving prompts and telling other things. But heck, software engineering has evolved before. There was once punch cards. There was once having very, very low level forms of programming. Then we got these higher abstracted languages and we got scripting languages. It got a lot easier. Heck, when I was doing iOS development, they were all excited about Xcode's like visual GUI framework for assembling text boxes. You barely needed to code to build the app was what they would pitch you on. Of course, you still needed to code. It was kind of bad. So I feel like there's always that feeling in the air, like maybe you're not going to code, but that's if you're becoming an engineer because you just want to write a bunch of code, it's kind of the wrong reasoning, I think. You should do it because you love building and creating and shipping stuff, and you should be using every tool available to you at the time. That's just a means to an end. So it's never been easier, I think, to get involved. It's never been kind of more fun, and the ceiling and what can be created is as expansive as ever. So I would thoroughly encourage other folks to get involved.
So I like what you said that, software engineering is all about solving problems and building things, right? So as long as that's the goal, you like doing that, I think software engineering is maybe one channel that people can use to actually do those things, right? And I personally myself also kind of like enjoying my software engineering again, simply because like you said, right? There are so many different languages these days, right? If we want to pick up a new language, it's quite easy to ask AI to kind of like kickstart the process, and you use kind of like your experience to actually accommodate, right, the software that you write, the architecture that you want to build, and things like that. So definitely today's topic is all about code review, right? It's one aspect of the software development workflow that everybody, I'm sure, is kind of like getting disrupted as well, right? Because now the code is being churned by AI, and at the same time, right, there are also tools like what you are building, right? AI that is reviewing someone else's code, right? So maybe let's start in the first place about the code review. What do you think the importance of code review for software development these days?
Yeah, the importance of code review. I really think it's kind of evolved over the ages. Again, I've only been professionally engineering for 10 years, but I've read a lot about the history of this. And from what I can tell, people have been doing forms of code review as long as people have been coding. At certain points in time, the early points of time, it would be laying out the software physically printed on a desk, having people pour over it, doing bug inspections, really looking for faults, looking for errors, looking for things that are going to hit production because the cost of that is going to be exceptionally high. There's not modern mechanisms for catching and reverting and rolling that stuff back. There's not even continuous integration tests. So it was a large obsession around looking for faults and bugs. I think as time went on into the 90s, it was still a little bit of that, but it was also a little bit more of collaboration and style. It might be desk checks. It might be asking an engineer to come and look over your shoulder at a computer screen and check and review some things before you commit it to a central server repository. And with the advent of GitHub around 2004, 2005, I think we really saw a flourishing of code review, partly because open source really needed it. Open source really removed a lot of trust-based barriers. It was different. You weren't within a company where someone had passed a hiring bar and you knew them, and if they made a major mistake or even a malicious mistake, they would just get fired. Now you're an open source. Now no one is trusted. Everyone's a stranger. Everyone's a pseudonym. But we're still contributing together. And so you have the advent of the pull request. It's a stranger requesting me, the maintainer, to pull in their changes. And so now I have this maintainer who's carefully, thoughtfully reviewing this change with deep skepticism, but also excitement. And you have a collaborative discussion going on in a forum-based web page. And you have that kind of the advent of what we see as like the modern code review. Now, that's looking for bugs. It's also looking for like, is this code change going in the direction I hope that this project is going in? It's maybe a little bit of teaching, even if the interactions are not the most long-lived. As time goes on further, I think you then have the advent of CI gaining deep popularity. I think throughout the 2000s, late 2000s, it was becoming much more popular. Always keeping trunk green. We never want trunk to fail builds and fail tests. And we start running that. We have the compute and the ability in the systems to now run that on every single code change before it merges in. So now I'm looking a little bit less for bugs. I'm still looking for bugs in code review, and I still care about that. But honestly, if that's how we're catching all of our errors, that's kind of a last line of defense. It's a kind of a flaky way to find, but issues we should also be finding those in testing systems and in careful rollout systems. But what's the point of code review now? Well, I still have a trust-based system, but internally within companies, I don't have to worry as much about that. I mean, again, ideally, we don't have too many malicious actors within a company, and I think the weight of it really starts shifting towards context and education and mutual understanding. It's a way to share what's happening in the code base. It's a way to share different subjective styles, opinions, and future directions. A really great place to have a discussion around, oh my gosh, is this where the code base is going? Is this where the architecture is going? Is in code review. It's also good to have that in a design doc review earlier on, but we're not all perfect humans. And if we're going to have it, let's have it before we merge in the code change. It's a great moment of teaching for a more senior engineer to show the ropes to a more junior engineer or a senior engineer just ramping up to a new system. It's a really good point in time to have these great discussions and feedback moments. So I think about that. That's code review, I think, up until the moment of AI. Then we have AI coming onto the scene, and it gets a little weird because now the code change wasn't necessary. It was either partially written by a human or maybe entirely not written by a human. It gets a little weird. Okay, so from a teaching level, I don't really need to teach the agent much about the system. Now, maybe, I don't know, maybe we'll evolve and like this is going to be a moment for like where agents get feedback and learn how to update their Claude code rules. Maybe that doesn't exist yet. But also the trust issue has kind of reemerged a little bit. Now, again, I actually don't trust it as much. My teammate, I have pretty good trust. We've been working together for, whatever, a year plus. This AI, it could be stupid. It could be malicious. I hope not, but like there's a higher risk of maliciousness. I can't sue the AI if it goes rogue. And it may just make silly mistakes or just not be smart enough or lack context that was clearly stated in a meeting, but this thing wasn't in the meeting, so it just doesn't know. And so the trust has gone down a little bit. So now I think we're re-entering a world where, okay, my gosh, more code changes than ever because agents and autocompletes and things have really created an explosion of code. That's great. It can be good. There's a lot of benefits that come from that. There's a lot of code and I trust it less. And heck, maybe no human in my company has ever read it by the time I'm getting to a code review. Now the code review is more important. I need to be more thoughtful in it, but I have more work to do than ever before. So there's kind of an emergent bottleneck. I think the simplest, like short-term answer is just as engineers, we're just going to take some of that time that we're saving from writing the code and we're going to shift it to more time-intensive code reviews. We'll kind of see how that evolves.
Yeah, I agree with you. It's a bit weird, should I say. So you write less code, but at the same time, you produce a lot more. And at the same time, you also review a lot more as well. Time will tell, right? So which direction it will go to. Maybe AI agents are going to be more sophisticated, more clever, and things like that. But hopefully, code review is still going to be like an important aspect of software development. So I'm a bit intrigued when you say about GitHub, open source, the trust-based system, right? In some debates within software engineering world, people say that they don't like the pull request workflow. But because of the advent of GitHub, I think many software development teams now kind of like adopt pull requests or merge requests if they're using GitLab, right? So maybe in the first place, let's bring this discussion, right? What do you think about the pull request workflow? Is it something that is kind of like a must-have for software engineering team, or some people actually prefers pair programming, trunk-based development, just merge into master straight away?
Yeah, it's really interesting. I think around 2010 era, there was a lot of different emergent patterns around pull requests. You think about different kind of ways you could organize your Git repository. You could do trunk-based development, but you could also do long-lived feature branches. You could do single commit pull request. You could do multi-commit pull requests. You could do squash and merge. You can do different merge strategies. There's a lot of variance going on. And what I noticed, I think, early in my career is it didn't seem like companies had the deepest confidence in their strategy. It felt like there was kind of an open debate around like, what is the best way to run this? And I think what's emerged is that there was patterns that made sense in open source, and they made sense in older styles of waterfall engineering. But those didn't make as much sense in some new closed source, faster patterns of engineering. So what do I think about? Like in open source, long-lived feature branches make a lot more sense. Forking patterns make a lot more sense. It's possible that we just want to have long periods of development in slightly different directions. And that's part of the beauty of open source, is that things can deviate and go in different directions. You can have forks of projects. You can support various things. There doesn't need to be a central dictator at the top saying, no, it's got to be this way. We got to unify and merge it all in and run the roadmap. That works in open source. That's beautiful. You also had a classic, hangover of, I think, older patterns of shipping software, whether you were shipping physical software and you needed to cut a release at a very specific moment in time that was going to be quite permanent. And maybe you want to fix that. Then you want to run QA and get some hot fixes into that, but you really want to like hold a stable release branch. And that also held up for a while in certain forms of mobile and certain forms of like shipping open source CLIs or libraries. You wanted these feature branches. On the other hand, you had, I think, a real progression in closed source development, partly spearheaded by great engineering cultures at Facebook and Google, and many companies that then fractured out of those early engineering teams that really centralized around trunk-based development. And they said, hey, realistically, we just want one source of truth, trunk, and we want to update it constantly. We want to iterate on it. And we don't really need to, it depends on the case, but in many cases, I don't need to publish long-lived feature branches. And I don't need a lot of forking mechanisms. I don't want there to be 3 different versions of truth in my company. And I don't even want multiple commits on my branch, because within a company, what started emerging, I think, is that the atomic unit of change was the thing being reviewed and tested. That was the unit. It was the PR. And GitHub, it all got a little bit weird because it was assumed that you would spend months on a pull request, iterating, updating it, and then that would get pulled back in as like a feature branch, merging back in the trunk. I think a pattern started dissolving in closed source. So you look at like Facebook, they create a pattern of diffs. They don't have a PR, they just have a diff. The diff is just one atomic block that is different from the trunk. And it can have versions. That's cool. So it can have versions, but it's just one thing. And other companies who couldn't rebuild it from scratch, they shoehorned it into GitHub. They said squash and merge. All right, I don't care what your commits were. I don't care how many like final fix, you put on this PR branch. We're just going to squash it and put it on a trunk. We're just going to kind of force that pattern. It's kind of weird because I think the whole industry got very excited about Git and GitHub, and then it's very cool software. And we just used it as our closed source systems for collaborating on code changes. But we were shoving a lot of stuff that was built intelligently for open source patterns. We started shoving it into these emerging closed source patterns. So now by 2025, I think, from what I can tell, and we work with a lot of companies, it really seems like there's a centralization around patterns. It really seems like everyone is kind of getting on board with trunk-based development. Everyone is kind of centralizing around single commit branches. Now, I know that that's the spicy topic. Some developers really love multiple commits, but I can tell you from the data, most companies just have squash on merge enabled, where like they don't, whatever you do with your commits, we're just going to compress that when we hit merge. And you even have monorepo patterns emerging. Again, monorepos don't make a lot of sense in open source. It's antithetical. In open source, I want as many diverse small projects as possible. Closed source, we have these monorepo patterns. So I don't know. Is the pull request going to still exist in the future? I do believe there will be an atomic unit of change that's going to get reviewed and tested and validated before it's merged in. That makes sense. That's true. That's valid. Does the name make sense? No, I think we gotta come up with a better name for this because once again, I'm just begging you to stamp my PR so I can merge it in. I'm not requesting you to pull in my changes to anything. That doesn't make sense. So the title's got to change. I think we can slim off a lot of these features. I think we can simplify it down to be a more simple construct. But the general idea, that's going to remain. We're still going to have code review. I think we're still going to have testing and some big processing step before integrating and deploying it.
Well, thanks for giving a little bit of historical context as well, like the different patterns people use and like how it got evolved to now, right? And I'm sure you have seen a lot of patterns by working with many different software engineering teams, right? And I guess in many parts of software engineering team, this is my hypothesis, like there will be a lot of them still using pull requests or merge requests, right? Simply because kind of like the version control system, maybe these days is about GitHub or GitLab. There's not many other options that people use.
Yeah.
And then inbuilt to those tools are the merge requests and pull requests. So if we can dive deeper into pull requests, I know Graphite being, the front and center about pull requests, right? Code review. What are some of the best practices of pull requests that you think you can advocate to the listeners here?
Oh, there's such an easy answer for this. I don't take credit for this. It's popular among the industry. It's timeless advice. Google, I think, did the best job of helping advocate and popularize this. Make your code changes small. I can die on this hill. This is an easy hill to die on. Is just in general, on average, caveat, but in general, make those code changes small. And what do I mean by small? I think a good size is like 50, maybe 150 lines, somewhere in that ballpark. Of course, I love saying this because then I get all these people in their armchairs being like, wait a second, one time I wrote like a 2,000 line PR and it was so good. One time I had to do a code mod and it was 10,000 lines, but that was the right decision. And so I love just it's a great way to bait people into getting really excited to give me an edge case. But I do think that in general, small code changes are good. Why are they good? I think with a small code change, you're going to get reviewed faster. That's great. Because why are you going to get reviewed faster? Because your team is going to get a notification. And if they see it's 50 lines, they're going, yeah, I'll just go review it. If they see it's 2,000 lines, they're like, I'm going to lunch. And like, I hope someone has handled this after. You just get all these people just like pretending that they didn't see it. Number two, the comments per line, the feedback per line of code you write is so much higher if your code change is small. It's so interesting. Not even per line, just even on average, just the number of comments a large PR will receive. I think once you start crossing like the 1 to 2,000 line boundary, you just start approaching like 0 comments. You just are so much more statistically likely to get like a LGTM, looks good to me. Whereas if I write a 50 line PR, I'm going to get some great feedback or some great discussion on that PR. So I'm going to get better feedback. If there's a bug, if there's a bug before I merge it in, okay, it's way easier to figure out what's going wrong on a 50 line PR than a 2,000 line PR. And then if there's an issue after I merge it in, well, heck, I'd rather revert 50 lines than revert 2,000 lines. So in general, I think small code changes are fantastic, but there's a reason that sometimes you write large pull requests. Like you can appreciate the wisdom that small is good, but we got a job to do. And the job is to go and actually ship a feature, build a system. And sometimes we end up writing large code changes. But why do we do that? I think we do that because there is fixed cost and slowdown around just the execution of any code change. And so if I need to change a lot of code and I'm doing it in small bites, well, I still got to pass CI on all those. I still got to go back and forth on a feedback loop. My God, the statistics around how long it takes to get a code review are kind of depressing. I think like the median is something around 10 hours. The average is something around 20 hours. The best like cases, like the P90, P95s are like 3 hours. Like it's quite depressing statistics. So you're incurring some high fixed cost there. Your CI, 30 minutes, let's say you pass it first time around. Then you got to merge that out. If you're lucky, that's pretty instantaneous. But if you're in a bigger company, that merge process, multiple release staging environments, that could take its own couple hours. So heck, with all this fixed cost stuff, like you don't want to be blocked. So why not just get a bunch of work into one of these things and then shoot it off? So you start really getting that temptation. And it's this chain of reasoning that led companies like, I think, Facebook, and then from the many people who descended from Facebook, companies like Twitter and Pinterest and many others, to start leaning on a stacked mentality. So there's this concept of stacking. It's very core to what we build at Graphite, but it's also just a popular thing that anyone can do. You can do this with open source technologies. You can just do this by hand if you're really hardcore. But the idea of branching off a branch, like why not have many small chunks of small pieces of work and break them all up? The benefit of doing this is you unlock parallelization. How do you make anything faster in software engineering? You parallelize it. How do I make my CI faster? I parallelize it. Same with my servers. It's like one of the only ways I can make things faster. So can I parallelize these annoying waiting times, waiting for a review, waiting for tests, waiting for deployments? Can I parallelize that and keep running code changes on top of that? If I can, then I get the best of both worlds. Then I get my small code changes and all the benefits, and I also can just write my code and do my job a little bit faster. So I think that's kind of the beauty of stacking, which is the premise of saying, don't just create a code change and then wait, and then create the next one and then wait. It's like, no. Do all the waiting in parallel and keep coding alongside. This has become extra important because that coding time is going down further and further and further. We're all loving using Cloud Code and Cursor and these wonderful tools. And we brag about how fast it is to code now. But again, those fixed costs haven't gone down. So now you really want that parallelization. So I think small code changes, yes, there's problems that emerge from that. Things like stacking, other systems do, merge queues. There's different techniques and technologies that then can emerge to assist in achieving that dream. And I think anyone who has tried creating really small code changes and attempted to walk that good path and been burned, I think it's for a lack of tooling and support, not because the original premise and idea was flawed.
Yeah, so I think the fixed cost is something that many people try to avoid, right? So whenever you raise a PR, first somebody needs to pick up, review, finish all the comments, get ready for merge, and then there's a CI build, right? And then maybe there's a bug, you have to go back, fix it, and all that. So I think the fixed cost that you mentioned can be really painful for some software engineering teams. And hence this stack PR thing maybe is like very helpful, right? In order to kind of like unblock developers so that they can pick up the next task, building on top of what they submitted, right? But some people maybe have not actually experienced this because Stack PR is not something that is built natively, maybe on GitHub or maybe GitLab and some of these tools, right? So maybe explain a little bit, what is Stack PR? You mentioned branch over branch over branch, but some people think branch over branch is not a good pattern. But why are we advocating for that? And what do you think are like some common benefits that people have whenever they adopt this Stack PR?
Totally. Yeah. So to go a little bit deeper on the pattern of stack PRs, and again, I don't want to I don't want to claim credit for having invented this. The Facebook engineering team, I'll keep calling it Facebook. I've not gotten the meta. The Facebook engineering team, they've been doing this for a decade plus. Like there's thousands, 100,000 engineers who have really tried and tested these patterns. Still a small fragment of the overall engineering population. And the other reason that a lot of people don't necessarily know about this is because it never made sense in open source. It's very interesting. So it never got that open source propagation of idea because open source moves slower. These PRs are open for a week or a month and they're long discussions and they're really thoughtful. And the idea of breaking them up into 10 small pieces and parallel getting reviewed, you don't need the velocity. The maintainer might not even want it because the maintainer doesn't want your piece by piece small ideas. They want the whole thing or nothing. They don't want you to commit half of it and then walk away as a stranger. Because I don't have trust. At a company, I trust that you're still coming into work tomorrow and you started this feature and you're going to finish this feature. And yeah, I want you to have like that continuous trickle-based development that's really healthy. I don't have to worry about you ghosting on me. So this idea, I think, has made wonderful sense in companies and it still makes great sense in companies, but it didn't get the lift off in the open source community. And it didn't get the native integration within tools like GitHub. Okay, but so to go a little bit deeper, what does it mean to stack pull requests or stack your code changes? Well, we all know what an individual code change is. You create a change, a commit, a branch, and it's based off something. And it's usually based off your trunk, your main, your master. Okay, so it's a difference off of the trunk. What if we create another change? Instead of stacking it on trunk, what if we stacked it on PRA? So now you have PRA, PRB. What's a real world example of this? Let's say we're coding up a feature for our website. What do I need to do? I need to go and update my server, add some functionality. I need to add a new endpoint. And I need to go and update my website to call that endpoint and then show some information to the user. Okay, so I could do this all as a 1,000 or 2,000 line PR, one shot thing. I could spend a day or two and code that up. Or what I could do is I could create a code change. I could first add some functions to my server. Fantastic. Boom, done. Let's shave that off. PR, put that up, start that clock for my code review for a couple of hours. Next, let me go code up that endpoint. And as I code up that endpoint that relies on that function, let me stack it on top. I need that other code. So let me stack it on top. We have PRA, PRB. Put that up for review. Now I got two things that are in parallel getting reviewed. Maybe by different people, maybe the same people. I'm parallelizing my testing as well. Then I start coding the client side, the update to the website that's going to fetch that new endpoint. Maybe by the time I finish coding that, the other code changes, maybe they're good to go. Maybe they're finally ready in that 3 to 5 hour interim. They're good to merge. I can merge them. I can wait. I can do whatever I want, but I'm unblocked there. And then I put up that third PR up for review. This wouldn't be possible if these were all stacked off of main, all based off of my main master. I need these to be based off one another. Without stacking, what would I do? I would either just keep bloating and adding to the existing PR, so people do that, but then and it's kind of cheating because sometimes you get a review and then you extend the PR and you're like, I'm going to piggyback that old stamp. Or you just wait and work on something else and you just can't continue that same idea. But here with stacking, I can break it up, I can parallelize the things, and I can also keep my chain of flow. So now, and I can zipper merge those, like cars on a highway, I can just zipper merge those into trunk and I can keep moving. And the net effect, I'm getting the parallelization and I'm never blocked. I just keep checkpoint saving, just keep just breaking off a little piece here. Now, it gets tricky. If I was to do this in vanilla Git, it works up until the point. The point that this stops working is the day that my teammate asks for a little bit of an edit on that first PR. They get back to me in code review and they're like, hey, it looks very good, but can we update this PR? And I'm like, oh my God, because I can update that PR, but now my Git pointers are all over the place. I am in like Git rebase hell now. Like I update that, now PR number 2, PR number 3, they're all over the place. Like the diffs look crazy on GitHub. It's a mess. And there are correct Git commands to run, but they are very complicated, like 3-point rebases with like raw hashes. And it is super painful. I don't care how good of an engineer you are. It is very painful to try and do that by hand. Imagine if it's a 10 stack. You do not want to go down 10 branches and perfectly reorder them and then perfectly resubmit them to GitHub and then perfectly update GitHub's merge branches. But this is where tooling, again, Graphite, I don't want to be too preachy, but Graphite, like this is part of the problem we solve is like, we will actually carefully maintain the pointers and like run the commands and update the remote pull requests and handle this. Same thing with Facebook's internal systems. Like what's the code doing behind the scenes? It's doing all that rearranging and restacking and just realignment for you. So you can really quickly make a downstack update and everything just flows naturally. You can get even more advanced too. If you build more advanced tooling, you can also merge in stacks and batches. If half of it or all of it gets finally approved and ready to go, great, one shot it in. So I can mix and match to what degree I'm doing things atomically. I'm doing things more in a zipper merge fashion, and it gives you a lot of flexibility and power. But that's the general premise, is creating these small pieces in a continuous work stream. In many ways, it's so funny. It's so reminiscent of a pattern we all know, which is like the original premise of Git commits. The original premise of Git commits is I have a branch and I'm creating many small little commit checkpoints. Why did that not work? Why does that not work in the modern world? I think what happened is that artifact history, but the unit of code change ended up not being the commit. It ended up being the branch. You don't test your commits. You don't review your commits. You review the branch. And so we needed a new entity, a new data structure to stack my branches. Ideally, we could have done this with commits and branches, but now it has to be branches and stacks. And we could simplify that. Now, if I can make every branch a single commit, I can start getting to a simpler world, and we start getting closer to what Facebook just rebuilt from scratch. But if you want to do this in a GitHub compatible way, you're gonna have to stack your branches. When we were first building Graphite, I thought long and hard. I'm like, man, can we just do this all with commits and branches? And the only reason we didn't go down that path was like, I just know people don't review and test commits. They don't merge commits. They merge in those branches. If I want to meet people and engineers where they're at, we're gonna have to do this on a branch level.
Yeah, so I think these days, like what you said, right, the atomic change is actually the PR or the branch, right? So people make a lot of commits on that branch, maybe a few trial and error, bug fixes and things like that, and then they raise a pull request, and that's kind of like the atomic change that a developer will submit, right? And I think thanks for trying to explain about stack PR. I know for some people maybe it's still kind of like a bit abstract, but the moment when you see an image or visualization, I'm sure probably it makes more sense, right? And when you work in a bigger, larger software engineering team where you have many different modules, more people, right? I think this stack PR also kind of like makes sense much better because simply of those, unbottlenecking the process of software development and merging into trunk. And uniquely, you have shared this before, right? Graphite as a software engineering team has actually a high velocity of software development, producing code changes and things like that. And you produced this statistic before, way back. I don't know how much differ it has been since then. Like you are in the P99 percentile of the software engineering team in the statistic, right? And you kind of like raise a lots of PR within this team. And funnily enough, right, the time to merge is actually longer. It's like within 3 hours and things like that. So maybe give us a glimpse of what is your statistics these days and why such things actually become like a superpower for the Graphite team.
Yeah, yeah. This blog post, this LinkedIn post I made a while back, maybe a year or two, year and a half ago, where I braggishly said our team is in the P99 of productive engineering teams. And it was kind of a spicy post. I like sometimes writing a spicy LinkedIn post. Why not? Your life is short, right? You know. But I wrote this post. I don't really love to brag, but I wrote this post because I kept getting asked by people, VCs and peer companies, and they would say, hey, Graphite, you guys sell software that makes engineering teams faster. Fundamentally, it's nice, and there's a lot of nicety and features and beauty to it. But like the reason people are buying this, they're making the engineering teams faster. If you're trying to sell productivity, you better be the most productive team around. Otherwise, how can you go advise these other incredible companies to be faster? You better be walking the walk. And I was like, I thought about that. I was like, yeah, and this team is amazing. And like, let me just go and braggishly write, some numbers about why we actually are insanely fast and be proud of that. Let's be proud of that. Huge caveat: measuring software developer productivity is like one of the most fraught things you can possibly do. You'll get crucified in every which way. It's a whole field. And if there was a true answer, I think the entire art would look very different. We don't go into performance reviews. We don't hire and fire people based on like single numerical metrics. We all know that. So that's kind of proof to me, like no one has ever really cracked what it means to measure quantitatively productivity. But that being said, I wanted to write a spicy post and people kept asking me about it. So, okay, like let's do it by number of changes merged and amount of code merged. I know it's a shallow metric, but like, let's just try that. And what you see is the Graphite engineering team is insanely fast. We're not the fastest. There's a few others. I'll give a shout out. The Harvey AI, last time I checked, the Harvey AI team, man, they ship code fantastically. I don't know what they're doing. I want to talk to more of their engineers, but they are also incredibly fast. I always just imagine they bring like a legal lawyer mindset to it, and they're just like they're so trained from the law profession, and then they somehow apply that to engineering. But they're also so there's some companies that are really scrappy and fast. But why does Graphite engineering team ship a lot of code, ship a lot of code changes? Why are we really productive along those measurements of productivity? We work hard and we're very smart, but we don't work the hardest. There's like teams who don't go home on the weekends. There's teams who have sleeping bags in the office. I think it's a bit screwed up. Like I want people to have families and not get sick. So, we work hard. I don't want people with sleeping bags in the office. And there's other teams who do that. What we do is we have parallelization and we, don't get blocked on things. Why do we do that? Because we use aggressively every tool that we build. We are stacking. We are doing all these best practices. We're breaking up our code changes. We're getting incredible parallelization benefits. We're merging things in batches. We're reviewing them in sharded fashions. And we're using AI code reviewers, and we're using merge queues, and we're using every tool in the toolbox to try and keep this engineering team as fast as possible. Because we're building it. It's dog fooding. It's a great thing. You should use the stuff that you're building. So we're using everything that we're building. And I think it leads to these advantages. Now, people always ask me, they're like, okay, hey, great. Your engineering team ships a lot of code changes. But if they're all just really small code changes, are you just like creating a different way of doing the same amount of work? But no, it's a fair question. But when we check the numbers, it is actually the case that the net amount of code being added to the code base shipped and merged in, also removed, because it's important to measure how much code you're removing as well. That is also higher in proportion to the changes being smaller. So my sense is that the net productivity is actually quite high. And why is it high? Again, I think we're getting the benefits of parallelization. If I had to put a single point on it, because the other interesting thing you see with stacking, I've tried to measure this because customers will be like, oh, so you're gonna make my code changes faster. And it's really subtle. The average code change doesn't necessarily get that much faster. It depends. There's a lot of like case by case, but the average code change, if it used to take 7 hours to merge, it might still take about 7 hours to merge. Why is that the case? It still takes a couple hours to get reviewed, still takes a couple hours past CI. Like those kind of like forces aren't inherently being changed, but we just parallelized everything. So you now have 10 code changes in parallel taking 7 hours to merge instead of just one blocking on another one. So we unlock these productivity gains. It was fun. I wrote that in that blog post that a lot of people messaged me, but live a little, write a spicy LinkedIn post.
Yeah, definitely as a dev tools, right? You're gonna do what you preach, right? So I think definitely a cool story to share, right? And I think the Stack PI is kind of like play a big role as part of the productivity that you guys have, right? And especially with your advocate about, small PR and, stacking a few changes in batches, I think that will be really cool. And I also use Graphite with my team, right? And we always love to see this weekly software email, like weekly in code or something like that, right? where Graphite will send you an insights based on your pull requests, right? So things like number of lines and always like top reviewers, top number of code changes, those kind of things is always something that we like to brag on. And yeah, I think those things are great, right? So definitely we can measure a little bit like software productivity and how much quality and how much velocity that you have simply by analyzing the pull requests. So let's move on a little bit to the AI code review aspect, right? Because now Graphite also has that tool. I think it's called Diamond. So, like you said, right, these days, maybe most of the code are written by AI, some maybe written by human, but also at the same time, AI is helping to review. I think this, as far as I experience it, right, it's not as mature as like human reviewing code. So, what do you think is the best use case for AI code review as of now?
The best use case of AI code review, saving face, not embarrassing yourself for your tech lead. No, I say that jokingly, semi-jokingly, semi-real. AI code review is so interesting to me. I think we are experiencing the emergence and the advent of a new pillar within the software engineering lifecycle that's here to stay. I am very convinced that from here on out, forevermore, every single code change we write at companies will be scanned by an LLM and it'll spot check it. In the same way that we all use CI. If your company uses CI and your company runs linters, I think they're also going to run an AI code review. In fact, we call it AI code review. People in the industry calls it AI code review. But I think that is more of a marketing term. If I was to be really engineering about it, I'd actually just call this a subset of CI. Because what is it fundamentally? We're saying that you put up a code change and we're going to run some compute in the cloud for 2 minutes. We're going to hum away and then we're going to give you some feedback and tell you that there's an issue or not. And like that's kind of what my unit tests do. This thing's cool because it takes like zero configuration. It's very flexible. It's very fluid. It's not brittle like my unit tests. So zero configuration, zero maintenance. That's really nice. But it's kind of just a new form of testing and validation. Just like my unit test, it's not going to catch everything, but it's going to catch some stuff. And at the right price, I'd rather have at the right price. And if it's low false positive, I'd always rather have it than not have it, And what's really creative about it, what's really interesting to me about it is actually, I think it's starting in some ways to supersede linting. Now, of course, it's not as deterministically correct as linting, but it's faster than linting. I run ESLint and we run, various linting patterns on our code base, but it takes like 5 minutes, 10 minutes sometimes to clone, to build, to then execute a deterministic linter. These LLMs return in like 30 seconds or less. So sometimes it'll actually just be the fastest way to like catch simple issues, even faster than building my code. It'll tell you it's not going to build. I find that really cool. But what's the utility of this? It's another way to check for certain forms of errors, mistakes, style issues, so on. So it's a really good way to get a first check of feedback too. You can start getting some subsets of what we get at a code review. I can get fast and I can get it before I bother my teammate. And as I've talked about in this conversation, I'd really rather get some feedback in 30 seconds than in 3 hours or 5 hours. That has a ton of benefits to me. I'm still contextually locked in. It's still paged into my human brain memory. So I have it, so I can go and fix it really quickly. Also, it is the most painstaking thing to wait 3 hours, get a code review, and have your teammate be like, yeah, it looks good, except please just fix this like one thing, and then I'll stamp it. Because then I can fix it. And then I gotta wait another 3 hours for my teammate to come back from lunch. And I don't want to merge this thing. So if I can reduce review cycles, and I can, by the time I'm putting it in front of my teammate, all the stupid stuff has been flagged, fixed, handled, and they can really start thinking about the higher level questions. What humans are still good at up until now. We'll see. It's causing a race. But I want my teammate worrying about like the architecture and where we're taking the code base, and does this make sense in line with the patterns? Is there a teaching moment? I want them worrying about that and not worrying about every single if statement and for loop and just, did I get this quite right and perfect? Some of the people who love on the team too, that we find tech leads really love this stuff too, because they can then go into custom rules files and custom style guides and really encode a lot of nuance. Some of these people are tired of going around the company and being like the bad guy and upholding some of these best practices. And now they can tell a bot to go around the company and be the bad guy. So there's a lot of cool emergent properties, but I think it kind of goes without saying, like, this is a pre-flight check. This is like a CI, but in the same way, you don't merge in your code after you pass CI. You merge in your code after you pass CI and get a human review. I think we're going to keep living in that world for a while, for security reasons, for context reasons, because machines make mistakes and can't be held accountable. We still need that human review. But man, it's cool. Man, it's useful. And I really think everyone spends hundreds of dollars, thousands of dollars on CI and testing. I think we'll also be running this out of that same bucket as well.
Well, definitely makes sense right now that you mentioned about it, right? So we should just think of it like one aspect of CI, like the gatekeeping process, right? to actually find issues, errors, style divergence, right? So within seconds, right? So because this LLM tends to have like bigger context and they can do pattern matching quite fast. So I think that's where we get the benefits. And I think in the spirit of shifting left, right? I think there's also no blocker, so to speak, right, to run this on your local, right? So that you can actually catch all these issues using AI faster. Although these days, I think people use AI to churn out code, not to actually review it after they finish their work, right? But I think going forward, I could actually see the use case where you use AI to actually review your branch locally first before you even push it to the GitHub, right? So I think thanks for sharing that. Another thing that I want to ask you, coming back to the productivity of your software engineering team, apart from Stack PR, what do you think are the biggest levers within your engineering team that can actually produce much higher velocity and also being more productive?
So I can only speak from personal experience from one set of anecdotes as my experience at Graphite and the startup. So with the large caveat of, what works for us might not work for other people. We're case by case, but I can tell you some of the stuff we do. One thing we do, it's really simple, but we choose to be full in person. We're about, this recording, we're probably about 45 people in a room right now. It's kind of busting at the seams, so we're getting another floor in the building. But there are timeless advantages to just being face to face with all the people you're working with, even in a world post COVID where remote work is more popular and really beneficial to some folks, work life balance and things. But if you really want to optimize for the productivity of your team, I think it's very hard to beat just being in a room, having great, deep relationships with your teammates, being able to look them in the face and have a conversation, being able to get that tonality of voice, being able to jump to a whiteboard, being able to say things in passing, ideas, jokes, all these things, to be able to go on a coffee walk and muse about some big idea that you're hacking on. All this stuff really matters. I think about it, I once heard this term of like fidelity of communication. There's many ways you can communicate. You can Slack message, you can call, you can video call, you can just go get in a room with a person. There's different qualities and fidelities of communication. I think goes without saying that the highest fidelity is just two people in a room having a heart to heart or talking about something serious. And it's really hard to beat that. So we don't have unlimited time. No, every startup's in a rush. So let's use that time the best we can. Let's have really high fidelity. So we believe in that. Now it means many trade-offs. It means that we can't hire certain people remote who we'd love to hire. It means that it's a little bit less flexible of lifestyle for the people who work together. But we get that benefit. We get, and not just productivity too. I really enjoy and care about just people being friends, people I work with, and having deep relationships and caring about one another. Life is long, careers are long. And I think there's huge value in learning from one another, building relationships. One day we'll go to new jobs and careers and stuff, but we'll remember the people we worked with and we'll have had a really good experience. So I really value that. I think this is becoming more in vogue. This used to be weird. I would say this in like 2022 and people would be like, that's crazy. You're a full in-person startup. And now I think by 2025, it's like kind of back in vogue. So the pendulum swings. Other things we do, I don't think we do anything too crazy. We dog food heavily. One of our advantages as a dev tool team, it's not just, and I'm talking a little bit about like empathy and communication internally, but we also get it with our users. It's a great cheat code to be a dev tools company because our users are the same as us, the engineering team. And we do foster a culture of say, hey, like your feelings and ideas, you teammate I see on the team, it matters. Like if you are looking at the CLI, the website, the button, the merge, the stacking pattern, and you're like, this doesn't feel right. This could be a little bit better. You're probably totally correct because you are the user. It's not like we're building a healthcare thing or a financial service or a law firm. Like we're building dev tool. So your values and opinions matter. And what's great is we get to be in Slack channels with hundreds of user companies, such cool companies, everyone from like Figma to Notion to Shopify, these really cool companies that we build for. We're also in there with their engineering teams and we're just debating ideas and what are you doing for your best developer practices, and here's what we're doing. Here's how we're building it into Graphite. We're expanding our Postgres database. Hey, Notion, you had a great blog post about how you sharded your Postgres database. Can you get on a call and talk to us about that? And we're going to trade ideas. And they love that. They love that because they want us to be better and faster, more reliable because then they can use it. So there's this incredible synergy. And it's not everyone gets to play this game, but we get to play this game as a dev tool where us and our users, and that line is very blurry. I love to cultivate the feeling that we are actually just an extension of all these user companies. They go on Slack and they have internal DevTools teams, and then they also have a Slack channel with Graphite. And I want them to feel like we are just an extension of their DevTools team and have that relationship. And then likewise, internally, we get to really thrive on the feeling that like we are part of 1,000 of the coolest companies in the industry. We don't have to pick which one we work at. We work at all of them. We get billed for all of them. And then the last thing I'll say is then having a lot of trust and bottoms up feeling and empowerment to let people on the team then go and apply that. You don't have to go through 10 meetings and 10 approval processes to take that feeling and then update the CLI and update one of the commands. Let's actually trust the team. Again, we can cheat. We're small. When you're 45 people, you can pull this off. I get that at a 1,000-person company, it's a little bit harder, but let's lean. If we have the advantage, let's lean into it and let's really empower people to very quickly take ideas, change them, ship them, maybe put them behind a feature flag, but still get them out to production and let's iterate really, really quickly. We're a company about speed and velocity. Let's make sure we're really living up to that, both in our cultural practices, not just what we build as well.
Thanks for sharing some of these elements or recipes, how you build your engineering team, right? Because it's always cool to hear from different teams, right, how they succeed. And probably some of us also can learn about, building relationship, building trust, the fidelity of communications. I think that's really important as well, even though software engineers, some don't like to kind of like talk to each other. But I think it's always very important to build a relationship. And I think the cool thing about, you mentioned, right, working with other software engineers from other companies, right, collaborating, I think that's super fun. Speaking about those, right, like the hiring process, especially these days with the proliferation of AI tools, do you look at software engineer hiring differently now? What kind of attributes that actually you assess these days?
I don't think we do it perfectly, but we do it and we do it pretty efficiently and effectively, I would say. So we used to try to be as amenable as possible to the candidate. So it has changed a little bit. We used to be as amenable as possible to the candidate. We said there's pretty much 2 ways you can kind of interview, maybe 3 ways you can interview in software engineering, but at the very least, you can do some in-person or synchronous coding tests and conversational interviews. You can do some leak code stuff. You can architect on a whiteboard. You can talk about your former job experiences, or you can do a take home. And often it's a mix, but instead of a leak code test, you could give you a big take home and go do that. There's kind of a third door. We don't do too much, but there's also the whole game of work trials. They're kind of tricky, but there's a few predominant ways of engineering interviewing. They all suck. If you go online, you go to Hacker News and you look at any one of these, you will find haters for all of them. For work trials and take homes, people are like, how dare you? I have a wife and kids and a family, and you're asking me to do all this. And it's not paid. This is insane. But then you also look up 30-minute leak code interviews, and people are like, this is crazy. This is nothing like real software engineering. How dare you test me like this? Just ask me to build a thing. So it really is a lesser of all evil situation. Companies do all different practices. What I've noticed in practice is that take-homes are kind of dying a little bit, at least take-homes as we've known them. They become very low signal for us because they were always a little muddy in the signal. You might spend extra time on it, and how do I compare that? But now if I give you a take-home, you just you're going to run a ton of AI code on that. There's no doubt. Why would you not? Now what I'm trying to grade is what you've created with AI. Now, and to the credit of take-homes, I think there are progressive companies who are thinking about this and saying, okay, great. I actually expect you to use AI, and I'm going to give you a challenge that's so challenging that you better be using AI and you might still not complete it. And we're going to evaluate that correctly. And on top of that, I want you to describe the code that was created, and I'm going to get you in gotchas if you can't really reason about why the AI made certain choices. That's an evolving, I think, pattern of interviewing. I'm not confident yet enough to lean heavily on that practice, and I'd rather see the industry flesh that out a little bit more. What we choose to lean on is, for better or for worse, is algorithm style, synchronous coding questions, along with some classic architecture whiteboarding and some classic conversations about your former experiences. And I'll tell you, for all their evils, the coding interviews have a lot of merit to them. They're very preppable, no matter who you are. Anyone can go and just do some practice questions. So there's a little bit of fairness to that. A really smart new grad can pass them, and a really smart senior engineer can pass them too. So all walks of life can pass them. They're extremely standardizable, which again has really nice fairness to them. They're very respectful of people's time. Outside of the prepping, we're going to do this. We're going to do this in 30, 45 minutes. And we're going to get you an answer. So I don't need a week of your time from it. So there's some strengths to it. And also they're relatively cheat proof. I can sit there synchronously with you, and I can make sure an AI is not writing it, another human's not writing it, all this stuff. And for better or for worse, I do feel like the success correlation of them is still quite high to a person being very strong in the room. I get it. I get that your job is not doing leak code questions in practice, but for some reason, it still is the case that if you ace one of those questions, you tend to be quite strong in the room, I find. It kind of reminds me of SATs. Yeah, SATs are like nothing like what I do in college, but somehow they're still kind of correlated to being generally smart. And there's not a lot of better ways to measure in a fair way. So it's a lesser of all evils situation. We'll see. I'll see. I don't know. Maybe the industry will keep evolving, but I don't need to evolve this. This is my other belief about startups. It's like I can barely innovate on one successful business idea. I don't also need to reinvent the wheel on like engineering interviews. That's a separate, really hard problem. So let me just use what's already worked in the past, and I'm gonna try and innovate on dev tools.
Yeah, so definitely, I mean, the landscape has changed, right? The kind of works that developers are doing have changed, but I think the fundamentals kind of like stay the same. You still need to have a good system design, architecture, good algorithmic problem solving, I guess, right? So I think the code that you write also needs to be clean, tidy, and all that. So definitely those fundamentals have not changed as of now, but I don't know in the future, maybe near future that it might change. But definitely thanks for sharing that hiring tips that you have. So, as we go to the end of our conversation, I only have one last question for you, Greg. This is what I call the three technical leadership wisdom. If you can think of it, just like three advice you want to give to the listeners, maybe you can share your version today.
You mentioned you were going to ask me this, so I was trying to think a little bit about this. I have two. We'll see if I spawn a third idea, but there's two ideas at least that have come to mind here. I'm relatively new to technical leadership. I'll be very, very, very honest about it, but I'm doing the job and I'm in it and it's high stakes. So I'm trying to be reflective about it. One thing I have really come to deeply internalize, and like all wisdom, it sounds trite, but I've really kind of started to internalize this, which is the premise that people don't really mind hard, challenging work. I think there's a fear. I found this fear as like a new leader manager of like, I don't want to give people a ton of hard work. That kind of sucks. I think people don't really mind that. What people mind is not having the agency and the autonomy to go about delivering on that hard work how they want to. That's what sucks. To be saddled with something huge and to not be given the chance to do it how you want to do it. And I think a lot about this, especially when you work on a team of smart engineers who super intelligent, really good at problem solving. That's the whole reason. That's why they were hired. You gotta give these people. I think what I find is I really want to set people up. I want to remove ambiguity. I want to help set the what and give some nice constraints to the problem. And then I want to really give people free rein about how they go about achieving that, even if it's not how I would achieve it or how I'd come to it. There's a little bit of a disagreed commit. There's a little bit of trust built into that. Just a mutual respect that my ideas are not better than other people's ideas. And so I think, on one hand, yeah, I want to set people up with big challenges. I want to point them in the right direction, and I want them to be amazing and surprising and creative in how they go about solving those things. That's the first idea. Second idea that comes to mind is as I interview lots of people, as I work with lots of people, or as I grow this company, I am shocked by sometimes the lack of just excitement and enthusiasm. Excitement and enthusiasm is so cheap. If you want to go get a job somewhere, if you want to go join a team somewhere, impress a manager, just do something like one of the easiest, cheapest things to go do is just be super excited about it. Be chomping at the bit, have that smile on your face, be reading stuff up, be curious about it, be bringing that to the table. And of course, there's like a whole other layer on top of that of like polished execution. But at the fundamental, like there's a lack of people who are just really humble and excited. I interview so many people, I work with so many people. I'm like, if you just told me that this was your dream job and like nothing more in the world, like you're like, hey, I know might not be perfect. I'm just so excited. I want to prove you wrong. I want to work my ass off. And no one says that, but you just say that's so endearing and compelling to everyone around you. And I'm using the context of getting a job, but you can use it on an existing team on all this. Maybe there's a little bit of entitlement or arrogance within the software engineering field where people are used to being sold and not having to sell themselves as much. But I do occasionally meet people like this. I do occasionally find people who have this general excitement and attitude. Oh my God, it is so compelling. It's so endearing. I think it's partly what makes a good founder good in the eyes of a VC when they're good in the founder selling. They're bringing that energy. I think engineers holistically could benefit by leaning into that enthusiasm, that energy more. I think it's going to open up opportunities and trust, and people are going to conspire for your success because they're just rooting for you at that point. So those are my two ideas that come to mind. I'll email you back if I come up with a third wisdom.
No problem. So thanks for sharing those. Definitely, I can see you kind of like the people person, right? Always want to build relationship, giving people freedom, right? So definitely those kind of things, definitely many people kind of like love, right? To have a leader like that. So I think thanks for sharing that. And I love the mentioning about energy, excitement, enthusiasm, bring it to the table to your day-to-day work. Definitely can build a much, much bigger energy for the team and also maybe bring happiness for the team as well. So thanks for sharing that. So Greg, if people would love to connect with you, learn more about I don't know, Graphite, maybe your techniques of building a high-performing engineering team, is there a place where they can find you online?
Sure thing. Yeah. So of course you have our website, graphite.dev. If you want to follow me, check me out on LinkedIn. Oh man, has anyone ever said that? But come follow me on LinkedIn, Greg Foster. One day I'll get good at Twitter, but not there yet. And always feel free to shoot me an email, greg@graphite.dev. It's always interested in hearing ideas and from folks using the tool.
Right. So I'll put that in the show notes. So thank you so much, Greg, for today's conversation. And I hope that Graphite can popularize a lot about stack PRs and help improve people in terms of doing their code review and pull request workflow as well. So thanks for bringing that product to the market.
Thank you for having me, Henry. This is great.